Okay, so this is video 3 for quiz number 2. This should be the last of the videos for quiz 2. We left off with the manual reset low water cutoff here and how power comes down to terminal 4. And I clicked on the Honeywell Sola um, information manual, and I showed you here where J62 is enunciation, and really what I meant to go to, and it probably is better information, go back to the main menu and open up the Bryan Triple Flex IOM. And in the IOM, I'm going to go to page 40, and you will see that as I scroll through these, that not always does the page number here match up with the page number there, because obviously there's a few pages of the cover page and things that kind of screw up the difference between here and here. But on page 40, right here where it says 40, here is a fault code, and here is lockout and fault codes. And I think this is important information that you need to know. You have a column for whether it's a hold message, which means that the boiler is going to wait until, or the sequence is going to wait until it sees something happen before it goes on, or if it's a lockout. And you come down here, you'll see code 67 ILK interlock off. And it tells you if you have one of these issues, you need to check the wiring or check the interlock switch to assure proper function. And when they're talking about interlock switch, talking about things like low water, the low water cutoff, the high burner temperature, which is the next thing in the series circuit that we're going to look at, and then high gas pressure. But you can see that is a lockout. And the important thing to know is that if that low water cutoff locks out, and it would tell you you have a code 67 interlock off, and it would tell you that it's an A1 low water, you have to go to the low water cutoff, and you have to press the reset button on the low water cutoff. Once it's reset, then you have to reset the touchscreen. You have to push reset on the touchscreen because it also has to be reset. And that's kind of redundant, but that's what you'll see. A lot of the controllers are manual reset. When they cause a alarm, you not only have to reset it at the device, which in this case would be a low water cutoff, you also have to reset at the screen. So it's important to know that when it goes to A1, which is that terminal J62, I believe it was, that's what it's looking for, and that's what it will do is cause it to lock out. And you'll see there's several A terminals, and we'll get to all those. So getting back to the wiring diagram here, the next thing in the series circuit, once we get power through the low water cutoff, we know we have water in the boiler, is the thermal fuse. The thermal fuse is used to protect the burner. If the burner gets a crack in it, if it gets warped, if some reason the air-fuel mixture that's on the inside of the burner gets hot over a certain temperature, that thermal fuse will break, and it is a one-time fuse, or thermal cutout, just like a fuse. Once it breaks, it's gone. You have to replace it, and if you called Bryan to tell him you needed a new one, they would also want to sell you a new burner, because obviously something has happened to the burner. When you think about this type of a boiler, you're taking air and fuel, forced air and fuel under pressure, and you're mixing it and pushing it into a cone that is designed to allow the flame to burn on the outside of the cone, the mesh screen. If it burns on the inside, there's a problem. So this thermal fuse is actually set inside the air-fuel mixture inside the burner cone itself. Once you know that you have a good thermal fuse, you would have power from 4 to terminal 39. Terminal 39 has two other connections, and one of them comes down here, and that is the high burner temperature, or the A2 input. So this is another input, J61, that the boiler looks at, and it monitors the power there. If it sees that there is power on terminal number 2, that means that we've got power here after the low water cutoff. If it doesn't see power on terminal number 1 of J6, the alarm would say thermal fuse is open. It is looking at the difference between power here and power there. And you'll see that as we go through all of these series of safety controls, and everything we're looking at right now are safety controls that will cause a manual reset lockout. Like you saw, it is a lockout, and it has to be manual reset because all of these are safety devices. This device here, high gas pressure, the switch makes, or excuse me, the switch breaks. Here is the common and the normally closed terminal down here. The switch should be made unless there's a high gas pressure problem. And of course, you get power in on 39, goes out on 8, and here, wire number 8 coming down here goes to J75, which is the A4 input for high gas pressure. If there was a problem with the high gas pressure switch, the annunciation would say that there's an interlock problem, and it would tell you it was a high gas pressure switch. So on the terminology document, you'll find here is some information about the Honeywell gas pressure switches. Here are the two different versions. I shouldn't say two different versions, but two different types. You'll see this one has a reset button right here. Obviously, this is manual reset. If it trips, it has to be manually reset. And again, if it's a manual reset component that trips, you not only have to reset here, but you also have to reset at the touchscreen display. This one here does not have the button. It would be automatic reset. But you see, they make several different versions of the gas pressure switch. They make it for high gas pressure and low gas pressure. That's the major division of the two types. They make them at different pressure ranges. You see here that if it's a C697A, all the A's are going to be high gas pressure. All the B's are going to be low gas pressure, and that's kind of important to make sure that it's applied properly. If you found a C6097B wired up or installed as a high gas pressure switch, somebody put the wrong one on there, and it's happened before. They make both of them in an automatic reset and a manual reset. They make it in a flange mount, and they also make it in an NPT, which is a pipe thread, typically a 1/4-inch pipe thread. So the different model numbers, you get different configurations, whether it's high or low, whether it's auto or manual, and whether it's a flange mount or a mounts with a pipe nipple. Okay, looking back at the wiring diagram, here's the high gas pressure switch, and we know that if we don't, if we have high gas pressure at wherever this is located, there's going to be a problem, and we're going to get the annunciation. We're going to have to reset that. So it's kind of important to know exactly where this is at. And what I want to go to now, you go back to the main menu, and you can see I still have all these other things open up here. I'm going to go back, and I'm going to look at the Bryan Triple Flex IOM, and I'm going to scroll down to page 17. And here on page 17, you'll see this is what's behind the door. When you open up the door, when you look at the front face of the boiler, up here would be the control panel with the touch screen, and then the door opens up. Inside the door is your controller and your transformer and some of the electronic components. But let's take a look at for the gas train. Gas train comes in right here, goes up, goes into the burner. This right over in here is the pilot gas line. There's a pressure tap. There's a pressure switch there. There's another pressure switch here. But let's take a look at where the high gas pressure switch is located. It should be right up here. So I'm going to guess maybe number 33. So you scroll down and you look at all of these devices. There's a main low gas pressure switch, high burner. And I was looking for the high gas pressure switch. Maybe it's pilot gas pressure switch. Here it is. Main high gas pressure switch is number 13, pointing right to that right there. So number 13, main high gas pressure switch, manual reset. This switch should be set at 1 inch of water column above the maximum gas manifold pressure. So you look at a table, it'll tell you what the maximum gas manifold pressure is, and then you would typically set that switch 1 inch higher so that if the maximum gas pressure was exceeded by 1 inch, it would trip. But this is kind of how you will see where these components are located. Obviously, if you've got the door closed and you're looking at the touchscreen and you get an alarm that says high gas pressure, you want to be able to open the door and go right to the proper switch and push the reset button. But then after you push the reset button, obviously you want to figure out why that happened. So being able to identify these is kind of important. So I have a few minutes left on this video. I want to go through the safety circuit here with the rest of the pressure switches. So here was the high gas pressure switch. Here's the low gas pressure switch. If you turn the gas off to the boiler and turn it back on after the gas, if the gas pressure bleeds off or you lose gas pressure for any reason, somebody shuts off gas to the building, this is a manual reset low gas pressure switch. You'll have to reset it. Of course, you'll get a display on the alarm screen or the touch screen that says that there is a low gas pressure alarm, and you would find this right at the inlet pipe kind of down on the right hand side of the door when you open it up. That would be the low gas pressure switch. So we've got this series circuit that goes all the way here, and then you see it comes down and goes to a low pilot pressure switch. This is also a low gas pressure switch, but just for the pilot. It's downstream of the pilot gas regulator, so if there was a problem with the pilot gas regulator, you would know because this switch would trip. It has an enunciation point. High air exchanger pressure. I'll get back to that in just a second. We'll go back to the picture page. I want to show you that. And then here's the high burner pressure, and it also has an enunciation point. And then finally you get to the airflow switch, and I'll show you this also, but the airflow switch is the final safety in the circuit, and it goes over here to the airflow interlock. When there is a call for heat, it proves the low water, the thermal, the high, the low pilot, the high exchanger pressure, the high burner pressure, all the way through to the airflow switch, making sure the blower is running. And then you make the terminal here, and it knows that the safety circuit is complete. Okay, just a couple of minutes left on this video. So here is page 35 of the Bryan IOM, and this is really important. Here is pressure settings for all those switches that we just looked at. High gas, low pilot, high burner pressure, high heat exchanger pressure. You know, I'm going to put some of these on the quiz. You know, if it's a TF 150 through 200, if it's a TF 250 through 300, you know, what are the settings? You can see they're pretty much the same. So you may see that on there. Make sure you know how to get to the IOM, page 35. But before I run out of time here, let's go back up to the picture of the front door. Right here, this is where you saw the low gas pressure switch and the piping. But if you scroll down, here is the airflow switch, picture of the actual airflow switch. And you scroll down to page 19 here. I can get it to stop for me. Here is the side view of the boiler. There's a filter rack here. There's a filter that comes in, filter where the air comes in. Air comes through here. And here is the actual blower. The blower has an intake right there, so it's pulling air across the top of the boiler, forces air down through this air-to-air heat exchanger. Right here, number one, is your air heat exchanger pressure switch. Air goes through this heat exchanger before it goes up and into this tube that goes all the way up front and goes to the burner. Now the flue gases come through, and they go through that air-to-air heat exchanger and out the flue exhaust, which is right here. So you're preheating the air before it gets to the burner section. by running it through an air-to-air heat exchanger, heating it up with the flue gas.